over to Dr. Dayle Jogie.
Hello everyone, good morning. Thank you for having me, thank you for being here. So the theme of course is a math quest, and we have to discover and explore. Sometimes we just lack creativity. Sometimes we just lack self-belief. Sometimes we just need a little push. Sometimes we have issues with visualization. Sometimes we just need a little confidence. But the cool thing is, we have tools. We have technological tools. One of these tools is free. It's called Geogebra. I'm sure you guys have your data, and all you have to do is to type geogebra.org. Sometimes we have issues with our SBAs. How do we do diagrams? CXC is not going to accept pen and paper. They want professionalism. They want logic. They want creativity. They want savvy. But we have the tools. And this tool is free. GeoGebra software. How can we use it to visualize and solve mathematical problems? So let's go on a mathematical quest. As I alluded to, GeoGebra is a free online mathematics software. Has many capabilities: algebra, geometry, graphing, spreadsheet, statistics and calculus capabilities. Has an easy-to-use interface. That's the website. Once you have your data, you could just type it in, and you could start your quest. This is what you would encounter on the home page. You'll see several suites: calculator, graphing, scientific, etc. Scientific, you could literally type 1 + 1, you get 2. So I know you guys have your devices at school all the time. Instead of TikToking, we'll be GeoGebraing. Oh, miss, I forgot my calculator. I can't participate. No, you have your data. And you have geogebra.org. So these are just a few features of the suite. 3D graphics, geometry, graphing, CAS, that's an algebra system, and I'm just going to show an example later on how you can use this to differentiate. That'll be useful for the ADMATs and the sixth formers. And then there's probabilistic calculators as well. Now, I'm not saying, I am not naive. I'm not saying that you're not going to use your pen and paper. Certainly we need these attributes, these cognitive abilities. But we're not saying that you cannot use this as a tool to double check, or sometimes to visualize, or to have some inspiration. Let's say you're doing an SB and you're a group of 5. You don't know where to start. Where do you go? geogebra.org. So I say, let me start with a simple form 2/3 example. Boring. Solve a pair of simultaneous equations. All right, linear. So you could use substitution. You could have probably multiplied equation 1 by 2. You could double it and subtract, what have you. So go through it quickly, and you'll verify that the solution is x is 3 and y is not. I'll give you 5 seconds to do that. Now, of course, the theme is Math Quest. You have to be creative. You have to think outside the box. You say, well, that is pen and paper, but how can I use this tool? It's there. So I say, all right, you have your cognitive abilities, but start to think. What does it mean when two lines are represented as a system of equations? You solve simultaneously. What does it mean visually? Aha! It's a point of intersection. And of course, we go to geogebra.org and we just pull out the graphing calculator, which is part of the suite. And you literally just type on the top left, 2x plus 3y equals 6. Enter. Look at the green line. 4x minus y equals 12. Enter. Look at the red line. The what line? The blue line. We should have turned off the lights. But this will be on UWIMathFair.com, I believe, on the stream. So you could go back. And you just simply, immediately, you will see the pointer intersection, which is capital A. Now, the thing is, there's a problem. It looks like 3, 0, right? Right, it is. We're not saying no. But why couldn't it have been 2.9? That's sometimes a mistake you guys make. Because it looking 3-ish, I go right 3-ish. So we really need to, a 6-letter V word, verify. So we know we are a little lazy, but we're not that lazy. So what we could do is, we want to get a counter now. Say, aha, what is the location? Not just pure semantics. What is the de facto location of capital A? So you say capital A equals intersect, and it's a repository of instructions. As you type I, boom, it comes up. You just press enter, brackets. There are 2 labels. These are called handles. Notice on the top left, where's the handle of the green equation? EQ1. What is the handle of the second equation? You can't see it, eh? I apologize, but we'll check UWIMathFair.com. The next handle is EQ2. So you put intersect, brackets, equation 1, comma, equation 2, and you get the coordinates, boom, 3, 0. That, my friends, is the solution. Now, there's a Mickey Mouse question, will you agree? When would it have been really useful? Maybe if you have the intersection of a parabola and a circle. Interesting. So we have our pen and our paper, no problem. But we're using this to what? What is the V word? Verify. Ooh. I'll read it because I realize that we're blessed to have this big hole. So it's a bit difficult to see. Determine the center and radius of the circle with the following equation. X squared plus y squared plus 2x plus 4y plus 1 equals naught. Of course, we could work it out, pen and paper, and satisfy yourself of the coordinates of the center and of the radius. I'll give you about 20 seconds to look at that. Are you satisfied? Right, so we have the general form. Right, we don't have to go through the semantics. But we could see that 2F, we could compare to the number 2, 2G, the number 4, and we get our F and G. And then we get the center, negative F, comma, negative G, no problem. And then we get our radius. Cool length, but who feeling a little overwhelmed? They get a thumbs up or a thumbs down? Thumbs to the side? Neutral? Of course, we have Geogebra.org. Wow. Impressive and free. Not the data, but we're utilizing our data constructively. Now, all you have to do is to go onto GeoGebra and literally type the equation. Right, now to get the 2, anybody can tell me how you get the 2? Right, on the keyboard above the number 6 is a caret. I believe in French they call it circumflex. Yeah, so you just press Shift 6 and press 2 and you get x squared and so forth. It's very simple. Very easy text input. You type the equation, immediately anybody can tell me the center? It looked negative 1-ish, negative 2-ish. What about the radius? It looking 2-ish, but we're not sure. It could be 1.99-ish. It never sure. That's the mistakes a look at make. All you understand? That's a little error, right? You had a very fine. Let me go down the road. Aha. So now we go into the tools option of GeoGebra. Look under construct. Now don't take the semantics too literally. We're not necessarily doing a construction. It's just a label. So sometimes you have to familiarize yourself with these pieces of software. There is a learning curve. The learning curve is about 15 hours. But after that, you're on like corn. So it's worth the investment. I remember this is a math quest. This is what again? Discovery. So we click on midpoint or center. So let me tell you how to do it one time. All right? But they're simulating. There's a PowerPoint, so I'm not really clicking, right? So you click on midpoint or center, and then you literally click on the boundary of the circle, and boom, they give you the coordinates of A. Now, how can we tell the distance or the length of that radius? Do not forget your mathematical discovery. That is okay, don't worry. We will go back on UWIMathFair.com. So there were two parts to the question. One was the center. So again, we're not guessing. We actually want the center of the circle. And we also need the radius. How do we get the radius? So we have the center, and we take a point on the boundary of the circle. The radius is the distance from that center to that point. So all I do is I click that point, that is B. Boom. So I have the point A, which is the center. I have the point B, which is on the boundary. And then I click on GeoGebra, measure. There's an option called distance or length. I click on that. Then I click on the 2 points. Boom on A, boom on B. Whaps. The distance is 2 units. Boom. Remember what we're doing is verifying. Because you remember it could really be 1.99, we're not sure. And everything in mathematics is about accuracy and reducing your error. Now, what were the coordinates of A? So all you have to do now is click on that A. And then you'll get options. On the options now, you can go to basic and you'll see show label. We've clicked on A. It will give the attributes of A. It will say the name, that is A, and the value. The value is the location of the coordinates. Boom. That is the coordinates of the center. And the length AB is 2 units. That is the radius. Very simple. So let me go down the road. Now there's a CXC question from January 2018. It's kind of a precursor to linear programming. Not really, because it was just a section 1 question, so it doesn't actually go into the pure optimization. But certainly there's graphical work. So it gives you 2 straight lines, x plus y is 10, and y equals x. And then it tells you shade 4 inequalities. X greater equal to 0, y greater equal to 0, x plus y less equal to 10, and x greater equal to y. This could take some time. But of course, we have our software. No problem. So we go into GeoGebra and we go on the top left. You type x plus y equals 10. Boom. The line appears. Split second. Then you type y equal x. Boom. Second line. Very simple. Now we go down the road. We want to get our regions. Ooh. First one, x greater equal to 0. Now let's see what happened there. That is the purple region. One time, split second, it gives you that region. Now, the context of this question is the intersection of regions. So let me give you an idea. You go to Tyrico. Who like Tyrico? You get trapped in 4 currents. 4 currents. Where's the worst place to be? The intersection of how much currents? All. Yes? So that's where you want to the solution here. You want a mixture of 4 colors. And wherever the 4 colors mix, that is the solution set there. That is the intersection of all the inequalities. So there's the first one, that is purple. That is x greater equal to 0. If you contextualize, that is a half to the right. Come down the road now. Y greater equal to 0. There's a half upwards. All positive y's. So you can see the intersection now is a mixture of the red and the blue. So you see there's a quadrant. You mix 2 halves, you get a quarter. So far that is solution set. X greater equal to 0 and y greater equal to 0. You go down the road. X plus y less equal to 10. There's a green region underneath that green line. Well, let's see in. There's a green line here. I have it with the mouse. The green region underneath. So far, the region we have is a right angle triangle. I coming down, I go into the right, and I come up with a little hypotenuse. Are you seeing that? But I have a fourth current. Remember we in Tyrico is real water there? Boom. X greater equal to y. That is this line is blue. Remember we had the right angle triangle? But the fourth current now is underneath this blue line. So the solution is this triangle here. Almost like an isosceles triangle. That is solution to this equation. So you have the vertices 0, 0, 5, 5, and 10, 0. It's a bit hard to see, but Geogebra has a trick. It was hard to see because we mixed all the colors. So why don't we do an antithesis of that? Instead of shading the required regions, why not reverse it and shade the regions that are not required? That is called an inverse fill-in. So now the solution set is actually that which is unshaded, just for visualization. And it's free. The only thing that's not free is what? The data. All right, I have two more. So this one has to do with a certain topic starting with T. Close. Transformations. Very good. So the state the coordinates of R. You could see that that is 0, 3. No problem. But then they ask for two different reflections. One in the line y equal 1. That's a horizontal line. And one in the line x equals 0. A vertical line. Now look how easy this is in GeoGebra. I literally just create a polygon. Boom, 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 and close it. One time it's shaded for me. Just perfect for your SBA. With Windows 11, you just have to press Shift S. Yeah, the Windows button. Boom, it gives you a snip, copy, Control C, Control V into your Word document. That is it. What's wrong with that? Anything wrong with that? I don't see anything wrong with that. So you have your PQR. You have your line y equals 1. And then you're going to transform and put reflect about the line. Now here how you do it. This is how you do it. You click reflect about line first, or you follow the mouse. Then you click on the triangle. And then you click on the line. And immediately, boom, that appears. It's real amazing. But there's a second part. You're reflecting that now in x equals 0, which is the y-axis. So you repeat that process now. You clicked on reflect about line. Then you click on the object. And then you click on this red line, which is the y-axis. And boom, there is a solution to your answer. Now we're using this to verify. Cool, eh? Wow. So I'll go and close off just now. This is just the tip of the iceberg, guys. And remember, this is a math quest, discovery. Right? When you invest the time, you will get the results. So I just want to show application calculus. Very simple. So this uses the CAS, which is the algebraic system. So we're facilitating calculus through a derivative. Look how easy. You click on the calculator suite. You click on the drill down menu. You'll see these 5 options. You click on CAS, CS. Boom, this comes. It looks just like the other interfaces. but the engine is slightly different. It has its own repository. So I'll put f brackets x, just like this, equals x squared plus 3x plus 2. And it immediately plots it for me. Yeah? And all I have to do is press, so this becomes an object. I take that object now, so I take f. What the prime means, the prime actually means what? dy dx. So I just press f prime x. Boom! It differentiates for me. Now, no problem. I want to get the turning point. The turning point is the point for which dy dx equals 0. So I just press now solve brackets f prime x equals 0. Boom! It gave me the x value, x equals minus 3 over 2. And you could see it with GeoGebra. Because what we're doing, we verifying. Now the turning point will have a y coordinate. So you go down the road, you just put f brackets minus 3 over 2. You get the y value, which is the minimum value of the function. You have your SBA, no problem. You do a snip, Control C, go in your Word document, Control what? V. What's wrong with that? Nothing wrong with that. So just in concluding, this is an invaluable tool. Will you agree or disagree? Give GeoGebra a round of applause if all you agree. I agree. It's good for the classroom, it's good for home. It's good when you're bored. When you're bored, your teacher ain't come. You say, data A, you know how to really do some past papers. I want to double check if I'm correct, boy. Nothing wrong with that. Right? That is constructive, isn't it? It does not have a steep learning curve. You just go on YouTube, you'll find hundreds of tutorials. And it will assist your understanding of abstract concepts. Let me explain the 3 domains of learning. It's a holy trinity. You have affective, how you feel. You have psychomotor, like kinesthetic. And then you have cognitive, like the brain. To spark maximal learning, you want to use all 3, don't you? So this, of course, you'll have the visualization. And when all you see the nice colors, and all you feel okay, it's so good, they're real cool. Affective. And all that going into the cognitive functionality, because you're studying too with a book. You'll always get E. So you could use as a calculator, numeric and symbolic. What symbolic mean? dy dx. Numeric means 1 plus 1. You could use it for geometry, calculus, probability, and statistics. And the examples here are introductory, my friends. It has tremendous capabilities. This is a math quest, and I want you to explore. Thank you so much.